Hello my dear students, welcome back to my class in the series of learning programming in C. In the previous video, we discussed about the extend storage class. Well, in today's video, we will discuss about one more storage class and which is the most important storage class, which is static storage class. So what is the static storage class is going to do? How to use the static storage? Let us understand everything, each and every aspect of storage with some programming examples. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end and do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. And as I've seen the analytics of my channel, most of the non-subscribed people are watching the videos. Please do subscribe the channel so that it will be a motivation and encouragement for us so that we can come up with more videos. Subscribe to my channel and click on the like button. Static storage class. So what is the static storage class? So when a variable is declared as static, so when we declare the variable as static, it makes the variable to retain its value between function calls. Means the value of the static variable will not be reinitialized. It is going to retain its value between function calls throughout the program. Static variable will not be reinitialized. Means once we initialize to some value, it cannot be reinitialized. It will not be reinitialized between function calls. And when I apply the static to some global variable, it is going to limit the variable's scope to the file where it is declared. So for example, in a file, we have main function, we have many sub-functions. And of course, we all know the global variable will be accessed throughout the program lessons in the main function as well as in sub-functions. So it will be restricted to only that particular file. I cannot access this static variable among different files, like how we access extend variable among different files. The global extend is global variable. So that global variable can be accessed among different files. See, we are in a project, we have many files. So when we have extend, I can access that in many files. But with respect to static, its scope is only within the program in one file. It cannot be shared among many files. So how to use this and how we can retain the value of static, all these things will be understood with some program itself. That is how it is going to retain its value between function calls and how I can say it is not reinitialized. All these things we will understand with the program. So some basic things we'll know about static now. So how to use the static? So as usual, we have to use the keyword static, data type and variable name. So for example, static int a. So I have not initialized this. So if I have not initialized, what will be the default value? The default value will be 0 for static. For auto, it is garbage value. For extend, it is 0. For static also, it is 0. And talking about the location where it is going to store, it is going to store in the main memory, that is in RAM. Then lifetime. Lifetime means how I can use the static variable, till where I can use means throughout the program. In one single file, I can use in the complete file throughout the program, that is in the main function as well as in the sub function, I say. But lifetime and scope is quite different here. Now we get to know about the actual difference about lifetime and scope. So when I say lifetime, its lifetime will be throughout the program. But talking about the scope, it is only to the block where it has been declared. So it is local, means to the block where I declare it. So for example, I have a static variable declared here. I say static int x. So this x is only accessible within this block, means its value will be there here and I can use this variable only within this block. But its value will be retained throughout the program, that is lifetime. Its value will be retained throughout the program, but Its scope is only within this block. When I say I want to print the value of x, I can print the value of x here itself. I cannot declare in some, or I cannot use that value x somewhere else. But the value of that x retains throughout the program in the main function, subfunction. But talking about to print that value, I can only print where it has been declared. So I am printing it here in this block, but I cannot print that value here. But the value retains throughout the program. What is this actually? We have to understand only with the program. So when I say the value can be used throughout the program, it will not be reinitialized. But its scope is only to the block where it has been declared. So let us understand about this lifetime and scope with the program itself. But only the program can make you understand what actually the lifetime and scope is. So let's get into the program now. So here we go with the example program to understand static storage class, especially with the two aspects, which is lifetime and scope. So we have a display function declared here, the prototype, and the main function. Inside the main function, we have display function called twice. Let us see the code of display function. Inside the display function, we have two variables. One is the static variable x. It is not initialized, but the default value will be 0. We have automatic variable y, which is initialized to 10. Now, I have these two expressions to evaluate. I say x plus equal to 10 is nothing but x equal to x plus 10. So, what is the default value? It is 0. 0 plus 10, it is 10. Again, store it in x. The new value for x is 10. Then I say y minus minus, decrease the value of y, means it is y minus 1, 10 minus 1, it is 9. It is automatic variable, which is y. Then I say print the value of x and y. So what will be the output for this? For the first time, I have called the display function. So execution, as you all know, it always starts from the main function. We start from the main function. We call the display function and the control will be to this display function. Now I am executing this now. So I say x plus equal to 10, we have done it. Y minus minus, we have done it. And we are printing now. Print the value of x. So it is x equal to 10 and y equal to 9. So this block is done. And the scope of this static variable x is only within this block. But the lifetime is throughout the program. How the lifetime is throughout the program? Let's see now. So we'll get back to this, and once again the control to this. Once again I will call the display function. I'll come back to display function once again. Now, as soon as the compiler enters to this display function, enters into the display function, it will look into this variable declaration, which is static. So it's a static variable. As we all know, static variable will not be reinitialized. Means what the compiler will do, it is going to skip this statement. It is not going to reinitialize the static variable. The x value is 10, right? See, we have the location, say 200 here, and we call the display function, and the y value say location, say 400. Now once again we are into the display function. So when we enter into the display function, once again this location will be as it is. This location of the static variable will be as it is. It will not be reinitialized. But for y, I get a new location. Say for example, I get a new location in say 600 and the value of y will be 10 there. Right. Then I say x plus equal to 10. X is not reinitialized. As soon as the compiler enters into this block, this statement will be skipped because it is static variable, and static variable will not be reinitialized. The point that what we discussed previously, it cannot be reinitialized. Means the lifetime is throughout the program. Hope you are understanding this now. The lifetime is throughout the program. We'll come back to scope also. The lifetime is throughout the program. So x is available. X is still active. See, x is available. So once x is available and its value is also initialized. So when it is available and it is initialized, why we have to once again create it? Why we have to once again reinitialize? That's the question here. So x is available, x is alive, and the memory block is still alive, means the value is also alive. So I need not reinitialize. That's the point. The static variable will not be reinitialized. Understand this point. Now, I say x plus equal to 10 means what is x? It is 10. So it is 10 plus 10. What will be the new value for x? It is 20. So the new value for x, it is 20 now. Then I say y, it's a new block. It is 10 minus minus, so it is 9. So the new value of y will be 9. The new value of y will be 9. This will not be there. This will be vanished. But x is not vanished because it's a static variable. Y has been vanished. Once again I enter the display function. This statement has been skipped. It has been skipped. It is skipped because I should not reinitialize. I should not reinitialize the static variable. So x is like that only. So y, it is 9. Now when I say x equal to, print x equal to, it is 20, and print y equal to, it is 9. So the lifetime of the static variable is throughout the program. So once again I'll get back. Now what I'll do, I'll simply say printf, print the value of x. This value. I say x equal to %d, then print the value of x. What will be the output for this? You get an error message saying that x is not declared. Now I think you're understanding the scope. The scope of x is only within this block where it has been declared. I can only access this x in this block, not here, because x is not declared there. So the lifetime of the x is throughout the program because the value of the static variable will not be reinitialized. So it will be alive throughout the program till the end of the program. When the program ends, it gets vanished. But till the program is active, the x will be active. The lifetime is throughout the program. But the scope is local to the block where it has been declared. You can only print the value of x in this block, not in this block. But if it is a variable that is declared globally, I say static int a equal to 1, and I say a equal to %d print a, means that I am going to get back, then I can get here a equal to 1. As a global variable, I can access it anywhere. But if it is declared to a particular block, it will be local to that block. So local means it is the scope that what we are talking about. It is local to the block. But lifetime is throughout. The lifetime of static is throughout the program. It is throughout the program. So hope you have understood with this. Let us see the execution of this program. So here we go with the program to understand the static storage class. So we have the function called as display. So display function is declared here, and let us initially comment this global variable. Later we will see how this global static will work. So we have the main function, we are calling the display function twice. So let us get into this display function. So in the display function we have a static variable by name x. So the default value of x will be 0, and we have the normal auto variable which is y initialized to 10. Then I say x plus equal to 10, that is nothing but let me write it in comment, it is x equal to x plus 10. So then I said printf the x value and y value. So as it is the static variable, it is going to take the default value 0. It is 0 plus 10, which is 10 stored in x. So that is what I am going to print for this x statement. When I say y minus minus, so it is decrementing the value. So it is going to print 9. Again, I'll get back to the main function. I'm calling display function once again. Once again, I'll come here, and when I get into the display function once again, this particular line of the static variable will be skipped because it has already been initialized. We are not going to reinitialize that. Static variables will not be reinitialized. The value of x is 10 already. So then I say y equal to 10. This will be initialized once again. Then I say x plus equal to 10 means x equal to x plus 10, the value of x. So x is not reinitialized, the value of x is 10, so 10 plus 10, 20. So when I print x, it is going to print 20. First time I got 10, second time I will be getting 20. Now I say y minus minus, y is initialized, once again reinitialized to 10, so it is 9 only. So it is printing 9. So again get back to the main function, there is nothing to print. So let me save this program and run the program.
So run the program. What will be the output? Let us check the program now. Program output. See, x equal to first time display function x equal to 10 and y equal to 9. I got it. Second time once again display function, now x equal to 20 because x is not reinitialized. This particular statement will be skipped when I once again get into display function because static variables will not be reinitialized. It is holding the same value. So it is 10 plus 10 20. So it is printing 20. And y, as it is automatic variable, it gets initialized once again. It is 9. It is 10 and decreasing to one value, it is 9. So it is printing 10, 9, 20 and 9. Now what I'll do, if I just try to print the value of the static variable x, what happens? I'll just change this to x. So let me check this. You get an error now because x is local to that block, and if I just try to print x in the main function, I get an error message saying that the x is not declared. See, x is not declared, undeclared, right? So if it is a global variable, I can access it. Now what I'll do, I'll just remove the comment of this global static variable a equal to 1. Now in place of x, I'll say a. Clear this output screen. Now save this program, run the program. See, it is going to print 1. So I can access this global static variable anywhere. But if when it is a local static variable, it can be accessed only where it has been declared. So talking about the scope, it is local to the block where it has been declared. Talking about the lifetime, it is throughout the program. See, once when I am moving from one function to another function to function, the value of x is not reinitialized. It will be there throughout the program. So hope you have understood with the usage of static variable. That's all for today's video. See you in the next video. Till then, take care. Bye bye.